Welcome to Stoichiometry, Day 4. So it is Unit 7, Day 4. Today we're going to use balanced equations and defined quantities of reactants to determine which reactant is the limiting reactant and how much product can be made. So before we begin, you will need your notes and a calculator along with a periodic table. Okay, let's get started. So, a limiting reactant is the reactant that restricts the amount of products that can be obtained. This is really essentially what you run out of first. That limits the reaction. The excess reactant is reactant that remains after a reaction has gone through to completion. So this is like what you would have extra of. So, if we go back to our cupcake example from the beginning of the unit, how many cupcakes can I make if I have 1 dozen eggs and 3 boxes of mix? Remember our recipe, it was 5 eggs plus 1 box of cake mix will give you 12 cupcakes. So let's think about this in terms of limiting reactants and excess reactants. So what am I going to run out of first? Okay, so I have a dozen eggs and 3 boxes of mix. So if I follow this recipe, I only have a dozen eggs. That means I can only make 2 boxes of mix because I don't have enough eggs to use this 3rd box. So I can only make 24 cupcakes. That means I was limited by my eggs and I had excess cake mix. I ran out of eggs first. I had extra mix. Alright, so let's do another example. This one's in your notes with a grilled cheese sandwich. Here we go. A grilled cheese sandwich recipe is 2 pieces of bread plus 1 piece of cheese yields 1 grilled cheese sandwich. So here's our problem. How many sandwiches can you make given the following ingredients? Okay, we've got 100 pieces of bread plus 30 slices of cheese, and we want to know how many sandwiches we can make. Okay, so I can tell right now that I'm going to be limited by the amount of cheese that I have. We can only make 30 sandwiches, and that is because our cheese ran out. Our limiting reactant was the cheese. Our excess reactant was the bread. So we'll have a lot of bread left over. 40 pieces is going to be our leftover amount of bread. So we have excess bread at the end, and we ran out of cheese. All right, now let's look at this in terms of chemicals and compounds. So here is the reaction between magnesium and oxygen, and we want to know what we're going to run out of first. What are we going to run out of first in this reaction? Well, I can tell you right now we have a whole lot of oxygen in the air. The air is, there's oxygen all around us, but you probably only have a very small amount of magnesium. Okay, so our limited reactant is magnesium. We're only going to be able to burn that set amount of magnesium, but we've got lots of oxygen left over in the room. All right, so now we're going to think about how we could find our limiting reactant. First, you need to start with a balanced equation. For each reactant, we need to calculate the amount of product formed. And then once you get that, the smaller answer, so if we calculate two different amounts, the smaller answer will indicate the limiting reactant. It's what you will run out of first, and also the amount of product you can make, because you can't make more product. Like in our grilled cheese example, we could only make 30 sandwiches. Okay, we could only make 30 sandwiches, and that's because we ran out of our cheese first. We were limited, our total amount of product was limited by our amount of cheese. Okay, so let's look at our next problem. It says limiting reactants. Now this is the part I'm going to switch to document camera so we can look at the work. And here we go. So first we're going to start with that balanced equation. It says aluminum plus chlorine yields aluminum chloride. We have 2 aluminum plus 3 chlorine will yield 2 AlCl3. These are our coefficients. Now I'm going to look at my problem. We have to have 2 different setups. Each one of these will have 2 setups. So these take a little while. If you have the ability to, I would recommend maybe using 2 different colors of pens, just because it will help you differentiate between the 2 different equations you're going to need to be writing for each of these. So it says if 15 moles of aluminum react with 15 moles of chlorine, how many moles of aluminum chloride? So I'm going to do the aluminum first. Aluminum is going to be my first given. My unknown is going to be the same for both. It's moles of aluminum chloride. I'll do this first one in red. So always start with what you are given. This is a mole-to-mole reaction. We're going to do 15 mole aluminum. All these problems start the same. You write it out. Then I'm going to just go down, mole aluminum. And then I'm going to look at what I am looking for, which is moles of aluminum chloride. So mole aluminum chloride. Now I'm going to use my balanced equation. I'm going to use those coefficients. So I want to get the moles of AlCl3. There are 2. Compare that to my moles of Al. There are also 2. And then we can plug it in our calculator. Remember, you solve all of these the same way. You multiply the numbers on top, hit divide, and then if there were more than one thing, you would multiply all of those, but in this case, we're just going to be able to divide. So 15 times 2, that equals 30, divided by 2, and that is going to equal 15. So your answer for aluminum is 15 mole. Using aluminum, you can make 15 moles of AlCl3. Now we have to do the second part. So these ones are a little bit lengthy. 15 moles of chlorine gas. We also want to know the moles of aluminum chloride. So I'm going to do the exact same thing, except now I'm going to use this new given for using Cl. So I'm going to write it over here in green. So on this one, our given goes in that top left box, and that is 15 mole Cl2. I'm going to just go down, mole Cl2, and again I'm looking for the moles of aluminum chloride, mole AlCl3. Once again, I need to use my coefficients to fill in this part. Okay, AlCl3, this has a coefficient of 2, so that's going to go right there. But my moles of Cl2, I've got 3 right here. So we're going to solve it just like before. So in parentheses, 15 times 2, that is equal to 30, divided by 3. That is going to equal 10, okay? So using Cl, we can only make 10 moles of AlCl3. Now we're going to compare these numbers, okay? So our limiting reactant is the one that is smaller. 10 is smaller than 15. 10 is smaller than our 15. So our limiting reactant is chlorine. Our excess reactant is that aluminum, because we have 15. So that's a larger number. That's going to be the excess. So our excess is going to be aluminum. And guess what? Just like the grilled cheese, we ran out of the cheese first, so we could only make 30 grilled cheese sandwiches. On this one, we're going to run out of the chlorine first. So we can only make 10 moles of AlCl3 before we run out. So the limiting will give you this number right here. You can only make 10 moles of that AlCl3, the aluminum chloride. We can make 10. Okay, let's do another example. I'm going to make this. There we go. Okay. Once again, all of these, you're going to have two different givens. That's why I recommend using two colors. This one says, if 100 grams of aluminum, so here's my first given, 100 grams aluminum. And whenever it looks like, sometimes you'll see this on the test, and if you're not thinking about it carefully, you might be like, oh, why are there two givens? Well, if there are two givens, it's a limiting reactant problem. So that's what's happening there. 100 grams of aluminum react with 200 grams of chlorine gas. That'll be my second given. On both of them, they're going to have the same unknown, which is we're looking for grams aluminum chloride. And now I'm going to start. I'm going to start with the aluminum. And I'm going to put my first given in this box. 100 grams of aluminum. 100 grams aluminum. Just go down. Grams of aluminum. And 1 mole of aluminum. Now you have to use your molar mass here. So I want to know the molar mass is equal to 1 mole. So we're going to get this into mole form so we can compare them. And it is 26.982. That's the molar mass. Now this one's a little longer because we have to go from gram to gram. So now we need to compare. Okay, I'm going to just go down my mole Al. And I'm trying to get over to aluminum chloride. So I'm going to write up here mole aluminum chloride. And we're going to compare. We're going to use our molar ratio from way up here. Alright, so for aluminum chloride, I've got 2 of those, this 2. And for aluminum, I've got 2 aluminums, 2 moles of aluminum. But I'm not finished yet because, again, my unknown is looking for grams. Okay, so I have to do one more step because this is moles. And always what you have in that top right box, if it's not what you circled, you have one more conversion to do. Okay, so I'm going to just go down. I'm going to move down mole aluminum chloride. And to get it to grams, I can just set it equal because by definition, 1 mole of anything is equal to its molar mass. Okay, so grams aluminum chloride. Now I need to do another step to figure out the molar mass. Okay, so I'm going to write this over here. Molar mass of aluminum chloride. You have to figure that out. Our molar mass of aluminum chloride. So for aluminum, I only have 1 of those. So I'm going to take the weight of aluminum, which is 26.982. Plus the weight of 3 chlorines. That's because it's Cl3. So I have 3 chlorines, so I need to do plus, in parentheses, 3 times the chlorine, which is 35.453. And I'm going to plug that in my calculator. So, and here's my calculator. Remember to use your parentheses. Close them, enter. This gave me my molar mass. So my molar mass is equal to 133.341 grams. Okay, now I can solve to get the aluminums. I am all set up. These are a little bit lengthy, but they're not that bad. They take some time, but it's not that hard. So I'm going to put in parentheses 100 times 1 times 2 times 133.34 divided by new set of parentheses 26.982 times 2 times 1. Close. Okay. Here we go. Parentheses 100 times 1 times 2 times 133.341, close my parentheses, divided by new parentheses 26.982 times 2 times 1. Close your parentheses. Alright, then I'm going to hit enter. I got 494.185, so I'll round that to 494.19. So for aluminum, we've got 494.19 grams of AlCl3. So using aluminum, we can make that much aluminum chloride. Now we have to go back and do the same thing, but we need to use chlorine instead. So this is why it's handy to use two separate colors. Chlorine, we want to do the exact same thing. Okay, so with chlorine, remember that it's actually Cl2. So we're going to start with our given, which is 200 grams of Cl2. I'm going to just go down. Grams Cl2 in 1 mole of Cl2. Now we have to use the molar mass, and I have to remember that there are 2 of them because it is Cl2. So I'm going to say 2 times 35.453. So 2 times 35.453, and that's going to give me my molar mass to go in this first blank, and that is 70.91. Just rounded it up a little bit. Alright, so now I can just go down to get to my mole to mole conversion. So I'm going to just go down moles of Cl2, and I can't go straight to grams of chlorine without getting them both in the mole step. So up here I want to compare them. Moles of Cl2, and on top I'm looking for moles of aluminum chloride, and I'm going to get that from my balanced equation. So there are 2 moles of aluminum chloride for every 3 moles of chlorine. Okay, just go down one more time so we can get to our grams, because remember, that's what we're looking for from what we circled. It's the grams of aluminum chloride. To get to my grams up here. Grams is what we're looking for. So for every 1 mole of aluminum chloride, by definition, it's a constant, 1 mole is equal to the molar mass. And look, we already calculated that in the last problem, so I can just use that again because that has not changed. So this top box is the same. It's 133.341 grams. Now we're ready to solve. So in a parentheses, multiply 200 times 1 times 2 times 133.341. Close your parenthesis. Hit divide. And then you're going to multiply everything on the bottom. 70 in a new parenthesis, 70.91 times 3 times 1. Close your parenthesis and hit enter. Okay, so here we go. We've got 2 in a parenthesis, I almost forgot, 200 times 1 times 2 times 133.341. Close your parenthesis, hit divide, open a new parenthesis, 70.91 times 3 times 1. Close your parenthesis and hit enter. So, using chlorine, we can only produce 250 grams or well, this is actually 200, I rounded that too much, 250.72 grams of aluminum chloride. So remember, at the end, what you want to do is compare them. And you want to think, okay, so if I use aluminum, I can make 494.19 grams of aluminum chloride. But if I use chlorine, I can only make 250.72 grams of aluminum chloride. So that's the amount we can make. That's what we're going to run out of. So the answer is we can make 250.72 grams of aluminum chloride. Our limiting reactant is always going to match the amount you can make. It's the smallest number. Our limiting reactant is our chlorine. Our excess is the aluminum because it is a larger number. Great job. So I know these problems are really long and they take a while to do, but they are not that hard and they just kind of put together all those skills before. So when you're working on your homework, remember, try using 2 different colors if you can. It makes it a little bit easier to see, visualize what's going on. You're always going to have 2 different setups, and then you're going to be looking for the one that is smaller to find the limiting, which is going to match the amount you can make. Okay, so now let's head to your homework. Great job.